Okay, so in this class, we are going to learn about standard distributions. There are two ways जिसमें हम standard distribution को classify कर सकते हैं. One is the discrete, other one is the continuous. So talking about this class, हम discrete standard distribution के बारे में पढ़ेंगे. Next class में we'll talk about the continuous standard distribution. तो आप discrete के बारे में पढ़ेंगे और एक numerical भी solve करने का try करेंगे. In case you want extra numericals to be solved, please comment in the comment section. I'll try to come up with extra numericals also. So we talk about discrete standard distribution. So in this class, we will speak about discrete standard distribution. So standard distributions are of two types, discrete and continuous. So this will talk about discrete standard distribution. So how do we divide discrete standard distribution? There are 5 ways in which we can divide discrete standard distribution. One is the uniform. Other one is the binomial. Other one is the Bernoulli. Other one is the Poisson. Other one is the geometry. So there are two kinds of distributions. One is the discrete, other is the continuous. The discrete standard distributions can be divided in 5 ways. One is the uniform, binomial, Bernoulli, Poisson, geometry. So talking about first point जो हम पढ़ेंगे वो होगा uniform discrete distribution. So what do you mean by uniform discrete distribution? For example, if there are different values of x, imagine there are different values of x and corresponding is the probability of x. So there is 1, there is 2, there is 3 till n. So each value of x will have its own probability. 1 by n, 1 by n, 1 by n, and 1 by n. So it's equally distributed. So if there is a discrete random variable x, so if there is a discrete random variable, I'm sorry for the spelling mistake, discrete random variable x, each random variable from 1 to n, so if there are n distributions, 1, 2, 3 till n, each probability will have 1 by n. So this is 1 by n, 1 by n, 1 by n, and 1 by n. So this is about uniform distribution. Okay, you need to know two things very well because this will help you in solving numerical. The expectation of uniform discrete distribution is n plus 1 by 2, and the variance of x is given as n square minus 1 by 2. So there are there are different kind of distributions of discrete standard distribution: uniform, binomial, Bernoulli, Poisson, geometry. So the first distribution is the uniform distribution, in which you have different values of x from 1 to n, and each value will have its probability equal distributed, that is 1 by n. Hence called as uniform discrete distribution. The expectation is given as n plus 1 by 2, and variance is given as n square minus 1 by 2. The next kind of distribution that we have is the binomial distribution. Very important. Binomial discrete distribution. Okay. So what happens in binomial discrete distribution? So a random variable x. Okay, a random variable I am denoting as RV. A random variable x is said to follow. So please make a note of it also because this can come for you in your paper as a definition also. So you should know this. A random variable x is said to follow binomial distribution. A random variable x is said to follow binomial distribution If the PMF, probability mass function, this we have learned in the last class, the videos are already there on my channel, you can go through it. If the PMF is given as probability of NK, in which you have NCK, P raised to K, and Q raised to N minus K. So this is the PMF. So a random variable X is said to follow binomial distribution if the PMF is following NCK, P raised to K, and Q raised to N minus K, in which your N is the total trials, is the total number of trials. P is the success probability. Q is the failure probability that is there, and K is the number of successful attempts. So a random variable X is said to follow binomial distribution if the PMF P of Nk is following NCK, P raised to K, and Q raised to N minus K, in which N is the total number of trials, P is the success probability. So if you see, N is the total number of trial, P is the success probability, Q is the failure probability, and K is the number of successful attempts out of N. So if there are K total trial, so if there are N total trial, total, the K is the number of successful attempts. So that is about binomial distribution. The expectation value is given as first of all, I'm sorry. So basically, if X follows N comma P, where N is the total number of trials and P is the success probability, if you see, then expectation of X is given as NP and variance of X is given as NPQ. So this is something that needs to be understood. So a random variable X is said to follow binomial distribution if a random variable X is said to follow binomial distribution if the PMF follows NCK, P raised to K, and Q raised to N minus K, where N is the number of total trials, P is the successful probability, Q is the failure probability, and K is the successful attempts. That is the binomial discrete distribution. That is very important, in which expectation of X is given as NP and variance of X is given as NPQ, where N is the total number of attempts, P is the successful probability, Q is the failure probability. Next, you talk about Bernoulli distribution. The C part is the Bernoulli distribution. Bernoulli is nothing else than binomial distribution with N is equal to 1. Hence, if you talk about expectation of X becomes P and variance of X becomes PQ. So there are there are 5 kinds of discrete time distribution. One is the uniform, binomial, Bernoulli, Poisson, and geometry. In the uniform, if X takes different values from 1 to N, probability of each value becomes 1 by N. So the expectation of X is equal to N plus 1 by 2 and variance of X is equal to N square minus 1 by 12. The binomial distribution, a random variable X is said to follow binomial distribution if the PMF follows this particular law in which NCK, P raised to K, Q raised to N minus K, wherein N is the total number of trials, P is the success probability, Q is the failure probability, K is the number of successful attempts, and N is the total number of trials. So you have the expectation value, variance value, and you have the Bernoulli distribution in which this is a binomial distribution with N is equal to 1. So eventually expectation of X becomes NP, N is 1P, variance of X NPQ, that is PQ. And the final one that you have is the Poisson distribution. So this is the Poisson distribution. So you have the Poisson distribution. So what happens in this case? If now when is Poisson distribution applicable? If the total number of trials is much greater than that of the probability success. So if the total number of trials is much greater than the success probability, then Poisson distribution is applicable. And the probability of X for Poisson distribution is given as e raised to minus lambda, lambda raised to X upon X factorial. Okay, where n is the total number of trials. N is the total number of trials which is there. We have the P, which is the then you have the P, which is given as the success probability. So the P is given as the success probability. That is very important. So finally, your lambda is equal to NP, where N is the total number of trials and P is the success probability. So if a particular distribution has value of N much greater than that of your P, then I can apply this probability distribution in which N is the total number of trials, P is the success probability. Therefore, this lambda which is there is equal to NP. So I hope I'm very clear. So we'll try to solve one question and we'll try to understand. Okay. So let's try to solve one question. The question says, if X follows binomial distribution. So if X follows binomial distribution having, so if X follows binomial distribution having expectation of X is equal to 2 and variance of X is equal to 4 by 3, find the probability distribution of X. Find the probability distribution of X. That is very important. So if X follows binomial distribution, I repeat myself, if X follows binomial distribution with expectation of X is equal to 2 and variance of X is equal to 4 by 3, find the probability distribution of X. So in this, what we will do first is, as I mentioned, expectation of X for binomial distribution was what? NP, and variance is NPQ. So if NP is equal to 2, variance of X is equal to NPQ is equal to 4 by 3. Therefore, if I divide this, it becomes 1 by Q is equal to 2 upon 4 by 3. Right? So it becomes 2 upon 4 by 3. So if you just try to solve this question, this becomes Q is equal to 2 into 3 by 4. Right? So NPQ 2 upon 4 by 3. So your Q is equal to 6 by 4 is equal to 2 by 3. And P is equal to 1 minus Q, 1 by 3. So this is very important. So you have been given X following binomial distribution in which expectation of X value is given, variance of X value is given, and they ask you to find out the probability distribution of X. So you understood the value of Q, you understood the value of P. And now you have to find out the value of N. So expectation of X is equal to 2. Therefore, NP is equal to 2. N 1 by 3 is equal to 2. N is equal to 6. Therefore, if I have to write down the probability distribution, you know it's given as NCX, P raised to X, Q raised to N minus X. Therefore, it is 6CX. P value is given as 1 by 3 raised to X and 2 by 3 raised to N minus X. This is N. So this is the probability distribution. So in the question they told you that it follows the binomial distribution. Expectation and variance of X value was given. Find the probability distribution. You can solve in such a way. Okay, so that's it. Thank you so much.